Okay, so this will be about my framework or my botnet framework, Hydra, which is essentially a botnet, which is kind of a framework that many cyber criminals use to essentially conduct many different types of attacks on servers or just on the compromised computers. So, just for a little bit before the actual demonstration, perhaps a sort of visual representation would be good. So let's start with drawing a couple of computers. We'll just use squares to represent them. Okay, so these are kind of the three different levels. Perhaps, no, I wouldn't say with authority, but essentially they consist of an admin, a server, followed by the bots. The admin has control of the server, which the server has control of these bots. I'll just get rid of those. And the server is basically the hub between everything. It handles all the connections, whether bot or admin, and basically does everything. The admin is just a client, I guess, the hacker's computer. The hacker's client, I guess you can say. Part of my handwriting. And then this is the hub. And then the bots are just compromised computers that were infected by some sort of malware or Trojan horse that connected them to, or that unknowingly connected them to this server here. So we'll call them compromised. Okay. So essentially how it works is that first, the server acts on the commands of the admin, where, okay, there's a command that's sent by an admin where the server sends the same exact command to the bots, where if it's a certain type of command, whether it be like an information extraction command, data leaking, for example, the bots might have some sort of output, so they forward this output right back to the server, and then right back to the admin too. Of course, everything on the server would be logged in case something happens between the admin and server, because some random bug or exploit might have occurred. Okay, so these bots are basically under control of the admin, where the server is kind of a mask. And this is kind of because the server is hosted on a server, like on a random cloud server, for example, maybe on the dark web, I don't know. But like it could be anywhere on the internet. So I guess I'll have IPs for this server here. I'll do like 1.2.3.4, and then I'll call this 4.5.6.7. So the kind of difference is that if the bots somehow figure out that they've been compromised, any commands or any traffic that they might trace would go only to the server, and then hence would not be able to trace them to the admin. And this is a particularly good thing for the admin because an IP essentially allows someone to trace you to your approximate location, rough area, maybe a kilometer or something radius. Could be larger depending on where you are. And yeah, so for example, they would only be able to see the server that they connect to, which might be hosted in some entirely random spot in the world. So the admin has almost no way of being traced unless someone compromised the server and then something bad happened. Which is why these two clients, or these two parts in particularly, need to be secured in some way or another. Otherwise, there's going to be a lot of problems with this sort of operation. Typically, traffic's encrypted, or most important traffic at least is encrypted, which is basically how most servers work these days with HTTPS, for example. Because in the olden days, you might be able to spoof or send packets to a net or a router, and then the router might send you a bunch of internet traffic from another computer, which then you could look at the packets and find login data, which is really bad. Regardless, that's kind of out of scope. One of the problems or one of the attacks that these botnets can do are on servers. So let's call it. Oh, did my pen just? Oh no, there we go. Okay. So let's call this a website of some sort, perhaps a target. So the server, like usually, or like with the botnet, as usual, the admin would send some sort of command that kind of signifies that it wants to start a DDoS attack. I should probably call this DDoS, or distributed denial of service attack, which it's distributed because there are lots of bots that are attacking the server. Denial of service is what would happen if the attack actually works. Essentially, all these bots send in an immense amount of internet traffic to this website, where eventually it'll be so overwhelmingly large that the website would not be able to handle these requests and therefore go down. Put a sad face right there. And that's really bad because, for regular people, for example, you might have like an innocent person trying to connect to the server, but the server cannot send a request back because it's been basically taken down by these clients or these bots. Furthermore, there are many more things that these compromised bots can do because they're essentially running malicious code. So whoever is up there, the admin, they can put whatever they want into this payload, whether it be password stealing, malware, ransomware, etc. They can do a lot of things, and they can also get these bots' IP addresses, so you can also know approximately where these bots live. Hence why lots of people advertise VPNs. Again, that's kind of out of the scope here, but that's essentially what a botnet is or like a very simple level, and some of the dangers that it could pose to servers and the bots themselves. Because obviously you don't want to have your computer infected with malware. Nobody does.
Alright, so with my little topology being completed, why not have a hands-on demonstration of the, operation that I just explained? Alright then. So I've got the server configured already that has my framework. This Kali Linux machine that will have the admin script running, and then this Windows virtual machine being the bots that will just be compromised and I'll have remote access to via the admin on server. So to obtain this payload, I'm going to connect to Google just really quickly. I'll go on HTTP. Okay. So apparently my device is outdated for whatever reason, so I guess I'll just install the newest Chrome update. So I'll do exactly that. I'll install the update. Of course, I'm probably also going to need to first connect to my log into the server. So I'll do that right now. Alright. Okay, so now I have authenticated, so I'm going to run this update, or what supposedly would update my computer according to google.com. It's an unidentified publisher, so if you get something like this, if someone asks you to run some sort of file, never do it for whatever reason, but this is my script, so I know what I'm doing. So for demonstration purposes, I did not make this run in the background. I could have just used a pyw file and compiled that instead, but just to demonstrate that I actually have something that's going to run in the background, or a process that will be ran for the bot, that I just have this little terminal that's opened up, but I'm just going to minimize it. Anyways, there's a bot that just connected to the server. I've already approved the ID. I would have had some sort of ID message where I had to allow it. It's just a little security feature that I implemented so that there wouldn't be spam. in my server. Regardless, now that the computer is connected to my server, I have remote access to its shell and basically everything that it has. Oh, I don't know why I did that. Okay, anyways. Yeah. So I have the ability to run all these commands on this bot. It's quite a lot, and most notably include a ransomware payload, a password obtaining function, and of course the DDoS attack functions. So I have complete remote access to this computer, and I can do basically whatever I want on it. So I can list everything in the desktop, if it works, of course. It might take a while because this virtual machine is quite slow, and the encryption makes packets quite large. So that a problem would be that multiple fragments will be sent at a time, and then these fragments would have to be put together and then decrypted. So it might take a little bit of, it might take more than a second sometimes. But anyways, I do have complete access to everything here. As you can see, I guess all the files in the desktop are being displayed in a way. And here's a little update.exe that we just downloaded and ran. So I can open random files if I wanted to, but for this I don't really need to. Alright. And then I should probably do who am I, just to know who the heck's running the computer. It will just get the host name and username. So this is the computer name. Now I know what it is, and then that's the, I don't even know what the hell that is, but that's the person that's running it. I think that's pretty dumb, but yeah. Keeping things at a degree of professionalness. Yeah, there's a lot of that you can do. I'm not going to demonstrate everything because the main thing here is the DNS attack functions, and I need to configure a website that will allow me to test this this attack. Alright, so to demonstrate a denial of service attack, or more specifically a distributed denial of service attack, I essentially just ran the payload on my main computer over here. I'm just going to put it on a different display, but both bots are connected to my botnet, so I'll be able to attack the server from 2 different locations. So I'm going to ping the target website, and of course, yeah, I set up a beautiful looking target website. It's not too shabby, of course, but it's enough to at least demonstrate this attack. So I'll do that right now. And then delay of 0, of course, and then okay. So very soon we should be seeing at least a minor hit to this website. Oh, and immediately, I guess I just took it down. So, because, alright, let me actually just stop it to make sure that I didn't just have a placebo, or it wasn't a placebo effect. Okay, perfect. So the website works right now. I'll just restart the attack. I'm just going to copy this command. And then because of the immense traffic that's being sent to the server, it's immediately just going to be taken down, and I'll use Wireshark to demonstrate the amount of traffic that's being sent over right now, instantaneously. This is only from this computer right now. I might be able to get the traffic that's being sent from here. However, most of the traffic, because of this computer, is much faster. It's being sent from this IP address to this IP, which is just the website. As you can see, port 8000. Occasionally there's going to be things that are sent back, of course, but it's a little bit too much for my poor server to handle, and it's unable to handle the connections, and hence resulting in a subsequent denial of service. Also, there's a basically an immense ping spike over here. Typically it's in like the 1 digits, but because of the immense traffic that I'm sending to it, it's having a lot of trouble. So yeah, the moment I stop the DDoS attack, or it might take a second of course because it's still handling connections, but yeah, it goes back to double digits or primarily single digits. But essentially, yeah, I just took down this website with relative ease. All it took was compromising a couple of bots and really just setting up a little server to basically take control of everything that's going on right now and take down a website. Also, possibly to build onto everything. I could technically show the encryption just as an extra. Essentially, it's just going to be a bunch of base 64 bytes that will, when decoded, will have a cipher array with a bunch of values in it that are basically unusable if someone were to intercept and try to decrypt it. There's about 5 constants in my algorithm, maybe 6 because of the length of the block cipher. But anyways, that's kind of a demonstration of this denial of service attack to essentially take down a website, an innocent website, using a little bit of brute force. Alright.